Hello everyone, good evening. We will start the session within 5 minutes. Let's wait for everyone to join in. Hello, now it's audible. Okay, Yeah. Hello everyone. A very good afternoon to all of you. So let's start the session. So yeah, my name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur and the instructor for this course is Dr. M.K. Bhuvan, Department of Electronics and Electrical Engineering, IIT Guwahati. This is a week 7 live and interactive session on computer vision and image processing fundamentals and applications. So I hope all of you have gone this video lectures. So for asking and interacting, you can use the chat box. Otherwise, you can unmute yourself and ask your doubts. And also, okay, so last week I couldn't able to take the class for week 7 because I was not well, and now itself, so just why that's why it's delaying. So if I'm not audible and visible, just inform me. Okay, I'm audible and visible. So I hope I'm audible and visible. So this is our course layout. So for week 7, the topic covered for this week image descriptors and features. So we will solve some numerical problem based on this. Oh, okay. Actually, my voice is need not be clear because it's already I have mixed voice issue with it. Now it's audible. Now it's please just check your volume also. Actually, I have very bad cough and my voice is also gone. So we'll try to speak. Okay, it's already increased. So these are the some textbook and the references which you can follow for this course. And this is our first question. Okay, so first question is compute the edge direction and its strength at the central pixel, that is the direction and absolute value of the image gradient using the pivot edge detector. So the direction of the horizontal and vertical gradient of the detector is from left to right and from up to bottom respectively. So this is our image gradient, this one. So now we need to compute the edge direction and strength at the center pixel. So which one is our center pixel? This one, right? Six. What six? Yeah, okay. Center pixel is six, right? So how we can calculate this? So first, what we need to do? First, we need to identify the 3 cross 3 neighborhood pixels. Okay. So for the center pixel, so the center pixel of the 5 cross 5, this is a 5 cross 5 matrix, is 6 as we know that. So to apply the pivot operator, we extract it 3 cross 3 neighborhood image matrix. So which one is a 3 cross 3 neighborhood matrix? This one is, right? So the neighborhood matrix will be neighborhood 3 cross 3 matrix is 4, 5, 6, 5, 6, 8, 7, 8, and 9, right? So, so as we know that the pivot operator uses two kernels to calculate the horizontal gradient gx and vertical gradient, that is gy. Vertical gradient gy, and this one is a horizontal gradient. So what is our horizontal kernel for the pivot operator? That is called kx. That is already defined, rewritten, -1, 0, 1, -1, 0, 1, and -1, 0, 1. So that detects the changes from left to right. This kernel, horizontal kernel, detects the changes from left to right. And what is our vertical kernel? That is ky, and it is a -1, -1, -1, 0, 0, 0, 1, 1, 1. And it is used to detect the changes from top to bottom. Detects changes from top to bottom. Okay. So now we perform the sum of element-wise multiplication, that is also called the convolution, between the kernels and the neighborhood 3 cross 3 matrix. Okay, to find the horizontal gradient. So how we can multiply this one? So as we know that these two, and now we have to multiply to horizontal, to get the horizontal, this one and this one to get the horizontal gradient, and this one to this one to find out the vertical gradient. Okay, so I'm just taking one more slide to perform this. Now I'm writing here to perform a sum of element wise multiplications between kernels and the neighborhood matrix. So first we need to find out the horizontal gradient, that is gx. So just I'm writing it both here for 4, 5, 6, 5, 6, 8, 7, 8, 9. This is our neighborhood matrix, and neighborhood matrix, and our horizontal kernel is -1, 0, 1, -1, 0, 1, and -1, 0, 1. Now first we multiply these two. So if you multiply, just go by column. So first one is -1 into 4, right? Then next one is 0 into 5 plus 6 into 1 plus -1 into 5 plus 6 into 0 plus 8 into 1. Now the last rows minus 1 into 7 plus 8 into 0 plus 9 into 1. So here minus 4 plus 0 plus 6 minus 5 plus 0 plus 8 minus 7 plus 0 plus 9 would be there. Okay, so now if you add and subtract all these values, you will get 7 here. Okay, the horizontal gradient, you will get the 7. Now similarly, we need to calculate the vertical gradient as well. The gradient, that is gy. Similarly, if you just I'm removing it from here to write the vertical gradient. So what is our vertical gradient kernel? That is minus 1, minus 1, minus 1, 0, 0, 0, 1, 1, 1. So now similarly we have to do for the vertical gradient also. So minus 1 into 4 plus minus 1 into 5 plus minus 1 into 6 plus 0 into 5 plus 0 into 6, 0. Here it is into 8. Now next one is 7 into 1 plus 8 into 1 plus 9 into 1. So overall here you will get minus 4, minus 5, minus 6, plus 0, plus 0, plus 0, plus 7, plus 8, plus 9. So just if we add and subtract all these values, we will get 9. Okay. So now next one is if you want to find out the edge direction as well. So for the edge direction, that is calculated by edge direction, that is also called theta, is calculated by arctan gy divided by gx. So already we have calculated gy and g10. So now tan 9 by 7, right? Now if you just calculate it, you will get 0.909 in radian, 97 radian. Okay, just calculate these values. Already I have calculated. So the theta you will get 0.9097 radian. So now if you just go through the options, so you find 0.909 radian, 7 and 9. So option C is the correct answer for this question. Okay. So yeah, have you understand this question? Okay. So I hope all of you have understand this question. Now moving to our next question. So our next question is A is equal to 1423314150. This set of lines is given. So using Herc transform, we can represent this set of points by a line which slope and intercept are. Anyone having any idea how to solve this question? So the question is given, A is given. So given set of points is given. These are the set of points A. So using the Hughes transform, we can represent this set of points by a line whose slope and intercept are. So we need to find out the slope and intercept. Okay, so let's solve this problem. Here, So this for a given set of points, that is points are given, the line of best fit has a slope n and a y intercept. That is intercept is z. So slope m is calculated by the this equation, that is xi minus x dash and yi minus y bar, and where x bar and y bar are the mean values in the x and the y direction. Okay, and now next one is xi minus x bar whole square. So this is a formula to find out the slope. So first we need to calculate the mean values of the x and y direction. So if you just see these points, so these are the x and y, these are the x and y. So for that we have to calculate the x dash. So first we need to calculate the average of the all x values. If you see that, so 1 plus 2, only x values we need to take, plus 3 plus 4 plus 5, right? 1, 2, 3, 4 and 5. Okay. And how many total number of points? That is 5. So if you just add these values, so how much it will be there? 15. 15 by 5, we will get 3. Similarly, we have to calculate for the y also. So 4 plus 3 plus 1 plus 1 plus 0 by 5. Now add these values, we will get 9 by 5. If you just calculate it, you will get 1.8. Now put in this equation for these values in this equation slope m, then we will find out the slope m. So just I am putting here m is equal to, it is the summation of all the points are will be there. Okay, so xi means first one, here are 5 points, so here I will vary, I is equal to 1 to 5. Okay, so just we need to take each point and just subtract the mean values. So first value is 1, right? So 1 minus 3 x I minus, that means x1 minus x bar 3, and then multiplied by yi minus. So first value, so 4 minus 1.8. These are the multiplication. Now just take the another value x2. So you just see that 2 minus 3 and 3 minus 1.8, right? First we need to calculate here the numerator part. So now calculate for the next value, that is 3 minus 3 for this point and 1 minus 1.8. Now similarly for the next, so 4 minus 3 into 1 minus 1.8. Now for the next one, 5 minus 3 and 0 minus 1.8. Okay, so I'm just removing it from here. So these values so that we can calculate. Now, okay, I'm just writing denominator here as well. So m is equal to 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square plus 4 minus 3 whole square and plus 5 minus 3 whole square will be there. Okay, so now just take all the calculations. Just remove it from here. So overall m is equal to here we will get that is minus 2 into 2.2. If you just subtract it as minus 1 into 2.1.2 plus 0 into minus 0.8 plus 1 into minus 0.8 plus 2 into minus 1.8. Okay, and in the denominator you will get minus 2 square plus minus 1 square plus 0 plus 1 square plus 2 square. So now if you multiply all these values you will get minus 4.4 and here minus 1.2 plus 0 minus 0.8 minus 3.6 and here 4 plus 1 plus 0 plus 1 plus 4. So now if you add all these values, so in the numerator you will get minus 10 by 10, here 1. Okay, so the slope you will get minus 1, here it is minus 1. And now we need to calculate the c, that is intercept. Now using the point x dash and y dash that we have calculated, calculate intercept using straight line equation, that is y is equal to mx plus c. Here we will represent it y dash is equal to mx dash plus c, right? Y dash we know that is 1.8, m is minus 1 that we had calculated, x dash is 3 plus c, right? So c is equal to 1.8 plus 3, right? So overall you will get 4.8 and that is approximately equal to 5, right? So what we have got minus 1 and 5. So option A is the correct answer for this question. The slope we have got minus 1, that is here, and the intercept is 5, this one. Is it okay to all of you? Is it fine? Can we move to our next question? Okay. Okay, so I hope all of you have understand. Now moving to our next question. Now our next question is question 3. So for an image, the gradient magnitude and direction is given. After performing non-maximum separation, which pixel represents the local maxima? They are asking. So the image gradient, magnitude and direction, this is given. Now they are asking after performing the non-maximum separation, which pixel represents the local minimum. So here four options are given and in each option they have just indicated the pixel values. So now we need to choose which one is the correct one. Okay, so how we can solve this question? Anyone, any idea? Okay, so let's see the detailed explanation is here. So first we will see what is a non-maximum separation, and then identify based on that. So non-maximum separation is used in edge detection to thin the edges. So for each pixel, its gradient magnitude is compared with the magnitude of its two neighbors along the direction of the gradient. If the pixel magnitude is not greater than or equal to the both neighbors, it subtest that is set to the zero, then only local maxima are preserved. So if the magnitude is not greater than, or you can say that if it is a less than or to the both neighbors, then it will suppressed, otherwise it will be preserved. Okay, now next part is okay, now we need to analyze the gradient data. Whatever gradient data is given, we need to analyze. So in the image provided of the matrix of the gradient magnitude and corresponding gradient direction in the arrows for each pixel, we need to apply the NMS rule to identify the pixels are the local maxima along their respective gradient direction. So in this, these are the arrows that has been represented. We need to compare each gradient with its neighborhood. Then we need to find. So for our easy access, so if you see in the options, you can see in the middle two rows they have only marked this one. So now we need to compare the nearby pixels only. Don't compare each and one. It will take time. So in the options, you can directly see that only we need to compare this part because most of the outline part is in this one only. Three plus two neighborhoods. So for that we only compare. Okay, for the easy calculations and so now we need to apply the LMS to the central region. That's why we will apply only in the central region. Otherwise, you can also just compare with all other pixels, but you will not get the correct answer. To save our time, just check with the options which area or which they are just requiring. So just compare with them only. Okay. So now we focus on the pixels highlighted in the options only. That's why. So now pixel with magnitude 143 that is in the top middle here 143. Now this one is compared with this one and this one. Okay. No, only this one because it is not considered. We are considering only this part. Okay. To compare because they have marked only this part only in the option. Okay. So now pixel 143, that is in the top middle. So gradient points up. So neighbors along with the vertical direction are likely outside the visual matrix. So that's why we not taking this one. Okay. And the pixel with the magnitude 309 that is a below here. This one we will compare. So just a minute I can copy it and put it in the next slide so that we can able to just check. Okay, now it's visible. Very good. So now it will compare only this one because we are taking only this part, and this is the outside the range because in the options only this part is highlighted. Okay, so now if you compare these two pixels, so 143 is less than 309, right? 143 is less than 309 for first one. So the pixel should be suppressed. So this pixel should be suppressed. Okay. So this pixel should be suppressed. Now we will check for the next pixel. So pixel with magnitude 309, that is this one, middle left, this part. So now gradient point right, that means this gradient point in the right. And neighbors along with the horizontal direction are the pixel with the magnitude is 176 in this, but it is suppressed, it is not we are calculating, right? Because we are taking only in this area. Now the we will check with the right part, the 309. So that is a 398. So 309 is less than again 398. So 309 is less than the 398. So the pixel here also again the suppressed. Okay, so this pixel is also suppressed. Now we will check to the our next one. Yeah. Now 143, 309 on 9 next pixel 398 again. So the gradient point, right? That means this one, this one. Now again we will compare these pixels to the neighborhood pixels in the both direction. So 309 in one side, 408 is another side, right? So 398 is less than 408. So the pixel again here it will be suppressed and it is greater than, so it will be preserved in the right direction. Now again we will take the 408. Now again we will compare the so neighborhood along the vertical direction are the pixels with the magnitude 143. In the top, no, for 408 is 383, not a 4. So and 394 in the bottom for 408. The pixel bottom middle. We need to check. So 408 is greater than 143 because we are taking in the corner, and 408 is greater than 398. It would be 98. Here would be. So the local maxima n should be preserved because 408 is greater than the 398. Okay. Now we will again check for the 401. This one, this part. So gradient points in the right. So if you see that, so neighbors along the diagonal are the pixels with the magnitude 276 in the here in this side, and the top right and bottom left is 394 here in this one. So 401 is greater than 276, and 401 is also greater than 394. That's why we will preserve the local maxima. Yeah, someone is asking. We will compare in all neighborhoods. We will compare in all other left, right, top, and bottom in all the directions. In the diagonal point upward, yeah. So basically, what we have taken in the previous one. So 143 from here we can compare all the, but they have highlighted this part. That's why we are just focusing in this part. Okay, compare the left, right, and top and bottom. So for 401, we will compare the 408, 388. Yeah, 408. 388. Yeah, correct. Yeah, we can compare with that one only. But we will try to take. So 401 is less than 408. So just let me check. So just go with the options. In the options only you can just check for that point only. So you just check with the which option is suppressed or preserve the local maximum. If you have gone through the all the points, then it will be the some points it will be suppressed and some points it will be the preserved. So just check with the highlighted option in the highlighted part in the options. Just we need to check only that those points. It is matching or not now.
Hello, am I
Yes.
audible?
Yeah. You are audible.
Ma'am, if we are checking in the highlighted window, then
Yes.
401 is highlighted, so we have to compare it with the left, right, top and bottom pixels.
Yeah.
So, but then 401 will be suppressed, right, if we compare it with the left, right, top and bottom. Like if we compare 401 with 408 to on
Yeah,
left,
408 is there. Yeah.
then it should be suppressed. Then 401 can't be
So
the
in all
value.
the directions, would be suppressed. 401 is greater than 388, and 401 is greater than 391, and
Yeah,
408 is greater than is 398 as well. So maximum, I mean, it is greater than the in all the only 408 is greater than in that case. So from that point of view, you have to preserve this one in because in one direction it is giving only the less than.
okay,
In all other directions it is giving you the greater than, right?
okay, okay,
Yes, you need to check the different combination and permutation in that ways.
okay, okay.
Yeah,
Okay. But 401, then why has it been compared with 276? If you look at the last point, pixel with magnitude 401 bottom right,
yeah.
then even
Yeah,
if you
here some mistakes I have done actually in the writing. So I will just correct it
okay,
and send it to you. Yeah, then upload it.
okay, thank you.
Okay. Now it is understandable. It is fine.
Yeah,
Okay. If you see this option is the correct one. Option D. Just you check with each one. So only this 401 is preserving the local maxima. 408 and 401 point. So I hope all of you have understand this question. So can we move to our next question? Just we need to check with the different permutation and combination and we'll check which in the image gradient which in the magnitude and direction which will perform the non-maximum separation. Okay, maximum. Okay, so I hope all of you will understand this question. Now moving to our next question. So our next question is for the given 3 cross 3 image, that is this one, the texture of the image from the statistical information will be option A is a smooth texture, option B is coarse texture, option C is regular texture, or option D is none of these. So here 3 cross 3 image matrix is given. So the texture of the image from the statistical information will be. So from this image matrix, we have to tell where it belongs to which texture: smooth texture, coarse texture, regular, or none of these. Anyone would like to answer for this question? How to solve this question? Okay, so let's see the solution here. So the image processing, texture describes the spatial distribution of the intensities. So here is how we categorize them based on the pixel value. So first one is the smooth texture, right? In the option. First one is the smooth texture. So the smooth texture occurs when the pixel values are nearly identical or change very little across the image. For example, all pixel values are 115. It can be. So a smooth image has a very low variance and there is almost no roughness or change in the intensity. So this is called the smooth texture. Now next one is a coarse texture. So the coarse texture is characterized by the gradual constant change in the intensity values across a region. So in the given matrix, the value increases linearly by exactly 1. If you see that the image matrix is given 112, 113, 112, 111, 112, 113, then 1145. Every value is increased by 1. So as it moves horizontally and by 3. So if you just move in this direction, so it will be the move. And if it is a vertical direction, horizontal direction, it is a vertically. It increases the 3, right? So this that indicates the constant green or gradient. So as we have this 3 cos 3 pixels, so horizontal changes is from left to right, that is 112, 113. And if we move the vertically from top to bottom you see increases the pixel by the 3, right? Like 1111, 114, 117. So our next option is given regular or periodic texture. So that occurs when there is a repeating pattern of the values like on 110, 120, 110, 120 like that. It is repeating by the some values. Since these numbers just keep increasing and don't repeat the cycle, so is it a regular and traditional texture cell. So since in the pixel values in the matrix given so the steadily uniform progression rather than staying the same or smooth, jumping randomly, the statistical information that identifies this is a coarse texture. This is a feature of the coarse texture. Option B is the correct answer for this question, as it is increasing by 1 for every pixel value horizontally and it is increasing by a constant 3 values. Okay, so that's why this is a coarse texture. This is an example of the coarse texture. Is it fine? Have you understand this question? Okay, so moving to our next question now. Now our next question is again the matrix 3 cross 3 matrix is given. They are asking what will be the values of the central pixel after LBP implementation. After LBP implementation, what will be the value of the central pixel. So how we can perform the LBP implementation? So what is basically LBP? What is the full form of the LBP? Anyone knows? So LBP stands for local binary pattern. Okay. So now to calculate the LBP value for a 3 cross 3 matrix. So as already the matrix is given and the central pixel, that is, let's say central pixel is represented by GC, that is 10. Okay. So now what we need to do, we need to compare each of the 8 neighbors. Let's say neighbors we are representing GP to the center. And if GP is greater than equal to GC, assign 1, otherwise 0. Okay. So now just check with the each pixels. So first one is 17. So 17 is greater than 10, right? So assign 1 here. Now next one is 11. 11 is again greater than 10. Please assign 1. So 12. 12 is again greater than 10. Assign 1. Now next one we will move like this. Okay. Because this one is our central pixel, so don't need to compare with itself. It will give again a 0. Okay. So now next one is 8. 8 is less than 10, so assign 0. 5 is again less than 10, so assign 0. 3 is less than 10, assign 0. And 10 is equal to 10, assign 1. Because if it is greater than equal to, as 9 is less than 10, assign 0. Right? So now we need to write this binary sequence. So now the binary sequence of the matrix is that is triple one, zero zero zero, right? 0010. This is our binary sequence of the given matrix. Now we need to calculate the decimal value of the binary sequence. Can you calculate it? How? So 2 to the power 7 that values. Convert the binary to decimal. So 0, 1, 2, 3, 4, 5, 6, 7. Right? So now if you just calculate 2 to the power 7 is 128 into 1. So it will be the 128 only. The next one is 64. Next one is 32. Right? Now here all the values are 0. So you will get 0 at the end. 0, 0, 0. And here 2 to the power 1 is 2. So plus 2 plus 0. So if you add these values, overall you will get 128 plus 64 plus 32 plus 2 only. If you add all these values, you will get 226, right? You can calculate it. So you will get 226. If you check with the options, so you will see this option is the correct option. So the after implementing the LBP, the central pixel value is 10. Is 226 you will get. Okay, is it fine, all of you? Is it okay? Or any doubt, anything? Is it fine, all of you? Can we move to our next question? Okay, no doubts are there. So moving to our next question. Okay, so our next question is a point in image space is located at xy is equal to 3, 3. In the row theta hog space, what is the value of the row when theta is 45 degree? So how we can solve this problem? So a point in image space is given, theta value is also given. Now we need to calculate the row value in a row space. So how we can calculate this one? So as we know that the Hughes transform maps a point from the image space, that is xy, to the sinusoidal curve in the root theta parametric space, right? So I can write it here. The transform maps a point xy in image space to a sinusoidal curve in the theta, that is parametric space, using equation. This is the equation rho is equal to x cos theta plus y sin theta, and where rho is the perpendicular distance from the origin to the line and theta is the angle between the normal to the line and the x-axis. Okay, so for a point xy is equal to 3, 3 and angle theta is equal to 45 degree. So for a given point xy is equal to 3, 3 and angle theta is equal to 45. Now put in this equation, we will get rho, the value of rho. X is 3, already we know that. Cos theta is 45 degree, it is given. Plus y again 3 is given, and sin 45 degree. So now just calculate the values of the cos 45 and sin 45. So if you just calculate it, you will get root 2 by 2 plus 3 root 2 by 2, right? So 6 root 2 by 2. So overall you get 3 root 2. So this value you will get 3 root 2. So if you just check, option A is the correct answer for this question. Is it fine? To all of you, are you getting? Okay, so I hope all of you will understand this question. Now moving to our next question. So now again, next question is given. For a given image, calculate statistical moment M00 and M22 will be. So for the given image matrix, we need to calculate the statistical moment, that is M00 and M22. Okay, so how we can find out the statistical moment? So here it is given a 4 cross 4 matrix. So let's see where we read. So to find the statistical moment of the given 4 cross 4 image matrix, that is M, it is find out by this equation x and y or p y over q f x y. So from this equation we will calculate the statistical moment 00 and 22. Okay, and here x and y are the coordinates, that is row and column indices. Okay, so fxy are the pixel intensity at that and at that those coordinates. Okay, so first here we will find out M00. So what will be the values? So here x is by 1 to 4, right? It is a 4 cross 4 matrix. So 1 to 4, 1 to 1 to 4, and y is equal to 1 to 4. So x0, y0, fx, y, because p and q values are the 0. So now if you just further calculate it, so I'm just writing here x and y, fx and y. So as already told, fxy is a pixel intensity at those coordinates. So that means these values fxy are. Here x will vary 1 to 4. So when it is a x is equal to 1, so first we will open the y. So you will get here fx1 plus fx2 plus fx3 and plus fx4. Now we will open for the x. So here you will get fx1 f11 plus f12 plus f13 plus f14. Similarly, if you put in this 2, so you will get f21, f22 plus f23 plus f24. Now next one is plus f31 plus f32 plus f33 plus f34. Similarly, we have to put for f is equal to 41, f42 plus f43 plus f44. So that means all this first row and column. First row, first column, first row, second column, like that. If you just open this one. Okay. So now but just this, so simply it is a addition of all these values, right? Just showing how we can open this. summation. It is a y. So simple, it is a addition of all the image matrix for n 0 0, right? So 2 plus 1 plus 2 plus 0 plus 2 plus 2 plus 0 plus 2 plus 1 plus 2 plus 2 plus 1 plus 0. Now next one is plus 1 plus 2 plus 0 plus 2. If you add all these points, you will get total 20. So M0, 0, you will get 20 here overall. Similarly, we have to calculate for M22 also. Okay. So M0020 we have got. Now next we need to calculate for M22. Just I'm removing it from here. M2. So if you put here 2 x square y square, right? Fxy. Here we will get this only. X square y square fxy. That means coordinates square into pixel intensity, right? So now again the same. We can open first the first summation, that is y. The x will be value 1 to 4. If we open this one, so x square into 1 square fx1, right? Similarly for x is equal to 2, y is equal to 2. So x square 2 square fx2 plus x square 3 square fx3 plus x square 4 square fx4, right? You will you have we have opened the for y. Now similarly we need to open for the x as well. Just open this summation. So here for the first one, so here there will be a long summation will be there. So can I take in the next? Okay, I'm just taking the next slide because it will be the long. So actually this is our 1 to 4. Y is equal to 1 to 4. X square, y square, fx, y. We are opening this one. So we have opened for the y. Now we are going to open for the x. Okay. You can write it again. Okay, let me write it again because otherwise confusion will be there. X square, 1 square, fx 1 plus x square, 2 square, fx 2 plus x square, sorry, yeah, x square will be there, and 3 square fx 3 plus x square 4 square fx 4 will be there. Now open summation for the x. So here again for the 1. So 1 square into 1 square 1 will be. So I'm just writing 1 f 1 1 plus here again. So 4. So I'm taking a 1 and directly just multiplying with this one and writing. Okay. So 4 f12 plus 9 f13 plus 16 f14. Now similarly we need to put for 2 also. So here x is equal to 2. So 2 squared. So 4 f 2 1, right? And here 4 and 4. So 16, right? 16 f 2 2 plus here 2 again 4 into 9. So 4 into 9. I'm just writing 4 into 9. We will calculate it in the later. 4 into 9 f 2 3, right? And here again 4 into 16 f 2 4. Similarly, we need to do for the next for x is equal to 3. So 9 f 3 1 plus 9 into 4 plus sorry f 3 2 plus 9 into 9 f 3 3 plus 9 into 16 f 3 4. Now for the x is equal to 4. So here we will get 16 f 4 1 plus 16 into 4 f 4 2 plus 16 into 9 f 4 3 plus 16 into 16 f 4 4. So this is the whole summation equation of M22. Now we need to put all the value, that is F11, here 2, 1, 2, all these values in this one, and just multiply it. Okay. So already I have put it and multiplied it. So first one here, 1 1 is 2, right? So 1 into 2. So here we will get 2. Next 1, if you just 1. So 4 into 1 is 4. Like that we have to multiply and put it here again. F13 is 2. So 9 into 2. 9 into 2 is 18 and 1 4 is 0. So 0. Similarly for the next all those values we have to. So here we will get 8 plus 0 plus 72 plus 64 plus 18 plus again 72 plus 91 plus 0 plus 16 plus 128 plus 0 plus 512. So these are the values after putting and multiplying. Okay, now if you add all these values, so you will get 995. So M22 value is 995. M00 value is 20. Okay, after calculation. If you see just in the options, we will get option A is the correct answer for this question. Is it fine? Little bit lengthy and long question. So have you understand how to find the statistical moment M00 and M22 for the given image matrix? Is it fine to all of you? Have you understand this question? Okay, Ninad. Okay, so I hope all of you have understand this question how to solve. So now moving to our next question. So next question is using use of the which kernel results the following image. So this is our input image. After using one of these kernels, we will get this output image. So which kernel will be used to get the this result? Anyone have any idea? Would like to answer for this question? Anyone? Okay, so let's see the solution here, the detailed solution given here. So to identify which kernel produced the output image, we need to analyze how different convolution kernels, that is filters, detect edges. So first, we need to analyze the output image. So the output image is a result of the edge detection. To find the right kernel, look at which part of the building are glowing or the highlighted. So we will look into the output image, which part of the building is highlighted and glowing. Okay, so if you see this part and this part, this edges are glowing and highlighted. The top horizontal edges, the roof lines and the windows tops are bright, as we can see here. This one tops are bright, and the right vertical edges, the right side of the building columns and walls are right, like this right side, right? And the orientation, so notice that if the edges slanted towards the northeast, that is up, and to the right are the most prominent. Up to the right are the most prominent, that is most more glowing, right? So to understand how the kernels work, so number of these matrices are weight, and when kernels have positive value like 5, here the positive values are 5, 0, and here it is a 5, positive value is 5, and in a specific area the negative value is minus 3. So in the kernels it is given 5 is as a positive value and minus 3 as a negative value. All the kernels, if you see that, okay, it is minus 3. In the opposite area, it acts as a compass. So it highlights edges where there is a sharp changes in the brightness in that specific directions. So if you just check, we will go by options. So option A, there all the top coordinates are the positive and the lower are the negatives, and middles in the middle one is 0 and other two are negative. So in the option A, kernel in north, that is in the north, positive values are only at the top. It would highlight horizontal lines like a very top or the flat roof, but ignore the vertical wall. It will ignore the vertical wall. And in the kernel B, that is in the northwest direction, you can say, so positive values are at the top and left. That is top and left part. So it will highlight the edges facing the top left corner. Okay, and in the option C, if you see northeast, so positive values are the top and right. If you see top and in this right, this one. So that this matches our observation. It highlights the horizontal edges in the top and vertical edges on the right side. Okay, so that's why option C is the correct. In the option D, it is given is the positive values are on the right side. If you just see in the right side, we have only positive values. So it would be highlight vertical walls on the right, but wouldn't show the horizontal roof lines as clearly. This specific arrangement is the northeast Chris compass kernel, and that is designed to detect diagonal edges facing that degree. So the correct choice is the option B is the correct choice. Yeah. What horizontal edges is the? I didn't understand your question. What horizontal edges? Andina, you can unmute yourself and ask your doubt. I don't understand. Yeah, in the images, if you see, these are the edges, horizontal edges. This one, which is, if you see in the original image, so there is a line, something is there. So that is highlighting in the this right side of the kernel. Yeah, that is internal. So that is highlighted by the horizontal edges in the top. Okay, so I think it's fine for you. So now moving to our next question. So just check which uh, edges is matching or glowing. If you just check this side, this is a glowing, and this vertical edges are these are also glowing. So that is at the right, right side, and in the top with the positive values. So yeah, okay. I hope all of you have understand this question. Now moving to our next question. Our next question is which of the following statements of the Hooke transform is are false? They are asking for the false statement. So option A is parametric representation of the straight line of the line detection. Option B is mapping between the image space and the Hooke space. Option C is variant to scale and rotation of the image. Or option D is relatively insensitive to occlusion. So can you answer for this question? Which of the following statement related to Hooke transform is false? Okay, option C, variant to scale and rotation of the image. Okay, got it. So here we will discuss in the detailed explanation is here. So the Hooke transform is a robust feature extraction technique that is primarily used to detect shapes that can be defined by the mathematical model, such as a line or circle. So it is characterized by the parametric representation that it uses parameters like rho and theta to represent the line, so which avoid issue of with the infinite slope found in the phi is equal to mx plus c. So in the and the space matching. So it functions by the mapping points from the image space to curves, that is sinusoids, in the Hugh parameter space. And it is also occlusion resistance. It is relatively insensitive to the occlusion and noise because it relies on the global routing procedures. Even if the part of the line are missing, the remaining points still contributes to the correct peak in the accumulator. So our first option is, so this is related to the root transform. So our first option is parametric representation of the straight line for line detection. So this is a true statement. So the core of the transform is representing lines using the parameters that is rho theta to identify them in an image. And our next option is mapping between image space to Hugh space. So this is also true because we are mapping the algorithm fundamental mechanism is converting image pixel into the odds within the parameter space. Our next option is the variant to scale and rotation of the image. So this is false in the context of its defining characteristics because the transform itself is a method to find these parameters. So while the standard transform is sensitive to the changes that requires a new search, if the object scale or rotation is unknown, the property of the wing variant is typically cited as a limitation or false positive characteristic when listed alongside its core strength. So this is a false statement. And our option D is relatively insensitive to occlusion. So if we have seen the characteristics of the Hughes transform, this is a true statement. One of the primary advantages of the Hughes transform is its ability to detect lines even when they are broken or partially hidden by the other object. So the correct option is option C, that is variant to scale and rotation of the image. So option C is the false statement for the Hughes transform. Okay, I hope you have understand. So detailed explanation is given here. Okay, so now moving to our next question now. So our next question is which of the following is false about Laplacian operator? So here again we need to find out the false statement for the but here it is for the Laplacian operator. So option A is the edge orientation information is efficiently retained in Laplacian, or option B is Laplacian is an isotropic filter that is it produces uniform edge magnitude for all direction, or option C Laplacian is also very sensitive to noise, or option D Laplacian detects the edges at zero crossing. Which option is a false regarding to the Laplacian operator? Anyone? Then we will see the detailed explanation here. Okay, so let's see the detailed explanation here. So in the Laplacian operator, that is a non-directional isotropic filter, which means it responds equally to change in the intensity regardless of their orientation. And it is compute the second order derivative in all directions simultaneously. Okay, and it does not provide information about the specific direction of an edge. So below are the evaluation of all provided statements. Here it is given. So first option is the edge orientation information is efficiently retained in Laplacian. So this is false. So a major disadvantage of the Laplacian is that edge direction is not available. To obtain orientation, first order derivative operators like Sobel Privet are used. And our next option is Laplacian is an isotropic filter. So this is a true. It is a 2D isotropic measure that produces a uniform response for the edges in all directions. And option C is Laplacian is also very sensitive to noise. So this is also true. As a second order derivative operator, it significantly amplifies high frequency noises, and this is why it is often combined with the Gaussian filter, that is creating the Laplacian or Gaussian or LOG to reduce noise before edge detection. Okay. Now next option is option D, that is Laplacian detects the edges at zero crossing. So this is also true. Laplacian based method edges are identified at a point where the second derivative crosses zero. So the false statement about the Laplacian, the edge orientation information is efficiently retained in Laplacian. So option A is the false statement related to the Laplacian operator. So I hope it is fine to all of you. It's option A. Uh, Is it fine? Can we move to our next question? Okay. So moving to our next question. So our next question is in canny edge detection, what is the purpose of hysteresis? threshold. Option A to perform non-maximum separation. Option B to convert the image to grayscale. Option C to connect weak edges that are associated with the strong edges. Or option D to calculate gradient magnitude. Which option can be a correct one? In canny edge detection, what is the purpose of this hysteresis thresholding? Anyone would like to answer for this question? We will see the detailed solution here. Okay, see. Okay, we will see here the detailed explanation. So we will check by options. Yeah, correct option is C. So option A is to perform non-maximum separation. So this is a separate stage that occurs before hysteresis thresholding. Its purpose is to thin the edges by retaining only local maxima in the gradient direction. Okay. And option B is to convert the image into a grayscale. So grayscale conversion is typically the pre-processing step that performed before the scanning algorithm begins. So as a detector, it operates on the intensity gradients, not a converting the image to grayscale. So option C is to connect weak edges that are associated with the strong edges. So yeah, in the canny edge detection algorithm, hysteresis thresholding is the final step used to determine which potential edges are actual edges, which are caused by a noise. So it works using the two threshold values. First one is strong edges. The pixel with gradient magnitude above the high threshold are immediately classified as a definite edges, that is weak edges. Next one, pixel with the magnitude between the low and high threshold are considered as a weak edges. So these are only preserved if they are connected. That is especially adjusting to a strong edge. Now next one is noise separation. So pixels below the low threshold are discarded, and this mechanism ensures edge continuity by tracking and linking segments that belongs to a same physical boundary while filtering out the isolated noisy pixel. Our next option is to calculate gradient magnitude. So this is the second stage of the algorithm, usually performed using the Sobel operators to find the intensity changes in x and y direction. So yeah, correct option is C, to connect weak edges with the associated with the strong edges. The correct option is C. In canny edge detection, the purpose of hysteresis thresholding is to connect weak edges that are associated with the strong edges. Okay. Okay, so I hope all of you have understand this question or explanation. Now moving to our next question. Now our next question is, what does a single point in a Hughes transform rho theta accumulator array represent in the original image space? Option A single pixel. Option B, a straight line. Option C, a circle. Option D, a corner. Can you answer for this question? What does a single point in the Hughes transform group, that is root theta accumulator array, represented in the original image space? Okay, someone is saying option A. Okay. Okay, so let's see the solution here. So in the Hughes transform, the relationship between the image space, that is xy, and the parameter space, that is a rho theta, that is defined by the normal equation line, that is rho is equal to x cos theta plus y sin theta. Already we have solved one problem on that. So in the image space, a single point xy maps to a sinusoidal curve in the parameter space. So that represents all possible lines that could pass through that point. And in the parameter space that is an accumulator, a single point rho theta represents a unique straight line in the image space. The value rho is the algebraic distance from the origin to the line, and theta is the angle of the vector orthogonal to the line. So when multiple curves in the accumulator array intersect at a specific coordinate, it indicates that corresponding points in the image space are collinear and that forming the line defined by those parameters. So a single point in the Hugo commutative array root theta represents a straight line in the original image space, not a point. It is a straight line. Okay, so that's why option B is the correct answer for this question. So a straight line is used to represent a single point in a Hughes transform commutator to represent in the original image space. Is it fine? Have you understand how? Not always zero, it can be other angles also. Already we have solved one problem. Their angle is 45 degree. Okay, so I hope all of you have understand. Now moving to our next question. Next question is which of the following is a primary advantage of the LBP descriptor? Option A sensitivity to absolute light intensity. Option B invariance to monotonic grayscale transformation. Option C ability to detect line in a distance. Option D high computational complexity. Which of the following is a primary advantage of LVP descriptor? Any idea which option can be a correct one? Okay, so let's see the solution here. Yeah, local binary pattern, also called a LBP, that are primarily used in a computer vision for the texture analysis due to their computational simplicity and ability to describe local structure. So the key advantage of the LBP descriptor is that it is invariant to the monotonic grayscale transformation. That this means that if intensity of all pixels is changed in a way that preserves their relative order, that is a lighting variations, and the resulting LVP code remains same. So our options that are given, option A sensitivity to absolute light intensity, that is incorrect. LVP is robust, that is invariant to illumination changes. Option B is invariance to a monotonic grayscale transformation, that is a correct. LVP codes are invariant to a monotonic gray level changes. Already we have seen in the description. And option C is ability to detect lines in a distance. That is also incorrect. So while LVP can represent line, this is not its primary defining advantage. So our next option is high computational complexity. That is also incorrect. A major advantage of LVP is its computational simplicity. Right? The correct option is option B, invariance to the monotonic grayscale transformation. That is. So this is the primary advantage of the LVP descriptor. It is the invariance to the monotonic grayscale information. Is it fine to all of you? Have you understand? Okay. Okay. So I hope all of you have understand the explanation. Now moving to our next question. So our next question is if a G LCM matrix is mostly diagonal, what does it indicate about the image texture? Option A, the image has high contrast. Option B, the image is very noisy. Option C, the image has low contrast or slow spatial changes. Or option D, the image is completely black. So question is given if a GLCM matrix is mostly diagonal, what does it indicate about the image texture? Okay, option C. Okay, we will see the detailed explanation here. Yeah. So if a gray label co-occurrence matrix that is GLCM is mostly diagonal, it indicates that neighboring pixels have a very similar intensity values, which means that the image has a smooth or coarse texture with low spatial variation. So this structure corresponds to a low contrast, as there is a few rapid changes between the neighboring pixel intensity. So that is coarse and a smooth texture. Already we have seen, we have solved one problem on that also. If most entries are on or near the diagonal, it implies the pixel value of value I are mostly neighboring with the pixel value of j that where I is approximately equal to j characterize characteristics of a uniform slow changing image. And low contrast, so a diagonal GLSCM indicates a high degree of uniformity, that is homogeneity, and low amount of local variation, often referred to as low contrast. And high contrast noisy means an image with high contrast or high noise would cause a GLCM value to spread out from the diagonal, and there would be a large differences between the neighboring pixel value. The correct option is the image has a low contrast and slow spatial changing. So if the GLCM matrix is mostly diagonal, then it will indicate the image texture has a low contrast and slow spatial changes. Okay, that is right. Okay. So I hope you have understand this question. So now moving to our next question. Now next question is also related to GLCM also, gray-level co-occurrence matrix. So which GLCM feature measures the local variation in the image? Option A inertia, option B entropy, option C contrast, or option D homogeneity. Which GLCM feature measures the local variation in the image? Which option can be a correct one? Okay, option C. Okay, so here we will see the detail here. So here we will check by the options. Yeah, energy, or you can say angular cycle moment, that measures the uniformity or repetition of the pixel pair. The option B is entropy, that measures the randomness or complexity of the image texture. Option C, that is a contrast, that measures local intensity variations or spatial frequency between the pixel in an image. That is specifically calculating the sum of the square difference between the neighboring pixel. Gray label values or high contrast values indicate high degree of local variation and sharp edges. Option D is homogeneity, that is inverse difference moment. It is measure the closeness of the distribution of the elements in the GLCM to the diagonal and indicates the smooth or similar texture. Yeah, so the GLCM, that is gray level co-occurrence matrix feature that measures the local variation in an image is contrast, that measures the local intensity variation. So yeah, option C is the correct answer for this question. Is it fine to all of you? Okay. So let's move to our next question. Now, our next question is, what is the maximum possible entropy for the GLCM of an image with four gray labels? What is the maximum possible? Here they are asking my maximum possible entropy. So how we can solve this question? So the gray label covariance matrix that represents a joint probability of the pair of the pixels. So for an image with let's say I'm just writing it here. Okay, see the detail here. So I'm just writing the GLCM represents the joint probability of pairs of pixels. So for an image with let's say NG gray labels. So here NG is given as a 4. So the GL is an NG cross NG matrix will be there. So here given NG is equal to 4. So total number of possible pair. Four cross 4, that is 16. Let's say it is M represented by M. So now they are asking maximum possible entropy. So that entropy, as we know that it is measure the uncertainty or randomness in any discrete probability distribution. The maximum entropy, let's say H max, is calculated by log 2 of M. Okay, so log 2 of 16. Now if you just go 2 to the power 4, so here overall you will get 4. So that is a 4 bits. So the maximum entropy that is this one, that is a 4 bits. So as we know that entropy measures the randomness and uncertainty. So in any discrete probability distribution with n possible states, the entropy is maximized when distribution is uniform. Okay, and the maximum entropy H max for a system M is equally likely states is that is calculated by this one. Therefore, if you check this, option B is the correct answer for this question. Not like that you have just solved it mathematically. Is it fine to all of you? Okay. So our next question is, what does the central movement mu 0 0 represent? Option A, a centroid of the object. Option B, the orientation of the object. Option C, the area or total mass of the object or the skewness. Which option is the correct? What does the central moment mu 00 represent? We have solved one question, M00 and M22 question. Okay, so let's see the detailed explanation is here. So we will check by options. So the centroid of the object. So this is calculated using the first order moment, that is mu 10 or mu 01, and divided by the zero order moment, that is mu 00. So it represents the center of the mass. Our next option is the orientation of the object. So this is determined by the second order central moment, that is mu 20, mu 02, or mu 11. And it describes the distribution of the mass along the axis. Option C is the area or total mass of the object. In the context of the image processing and shape analysis, the central moment, that is mu pq, is used to describe the distribution of the intensities or mass within an object. For a 2D binary image or a object, zero order moment, that is mu 00, represents the area or a binary image or the total mass for a grayscale images. Its simplest moment and serves as a scaling factor for higher order movement. So it represents the area or total mass of the object. And the skewness, that is a third order moment of that measures the asymmetry of the distribution. So correct option is option C, the area or total mass of the object. That is. So the central moment mu 00 represents the area and or total mass of the object. Is it fine to all of you? What does the central moment mu 00 represent? Okay, so I hope all of you have understood. Now moving to our next question. Our next question is, U set of seventh moment are designed to be invariant of which transformation? Option A, translation and scale only. Option B, translation, scale and rotation. Option C, rotation and color only. Option D, no transformations. They are variant. Which option can be a correct one? Okay, so let's see the detailed solution. So in the use set of a seven-moment invariant that are mathematically derived to remain unchanged, that is invariant, regardless of how an object is shifted, resized, or turned within image. So option is translation and scale only. So while U moment are invariant to this option is incomplete without it because it omit rotation, translation, and scaling, which is one of the primary feature of the seven moment set. So this is a wrong statement. Option B is translation, scale, and rotation. So this is the correct. U moment are a non-linear combination of normalized center moment, specifically derived by the to be invariant to these three geometric changes. That is the translation invariance, scale invariance, and rotation invariance. And option C and D are incorrect, as we know that rotation in color only. So movement describes the shape and distribution of the pixel intensity. They don't inherently provide color invariance. So standard hue movements are typically calculated from the grayscale or binary images. And option D is no transformation, that they are variant. So this contradicts the fundamental purpose of the movement invariant, so which is specifically designed by the Ming Kui Wu in 1960 for reliable pattern recognition. So correct option is the option B, that is a translation, scale, and rotation. So in the hue set of seven moment invariants that are mathematically derived to remain unchanged, that is a translation, scale, and rotation. So option B is the correct answer. Is it fine to all of you? Yeah, option B is the correct answer, Anand. Okay, so now moving to our next question. Given a 4 cross 4 image, this one, with only two gray labels, that is 0 and 1. The GLCMP, that is for a specific displacement, is calculated as using this one. So we need to calculate the entropy of this GLCM. How we can calculate? So as we know that the entropy H of a GLCM P is calculated by H is equal to where I H J is equal to 0 to n minus 1, n minus 1 Pij log base to Pij. So here Pij represents the probability of the specific pair of gray label, probability of gray labels at a given displacement. So here P is given. Now we need to put the values. So here minus, just open all the summations. So here you will get P00, right? Log base to P00 plus P01 log base to P01. Now similarly for P10 log base to P10 plus P11 log base to P11. Now put the values. P00 is 0.5, so 0.5 log base to 0.5, and all other values 0, 1 and 1 0 is 0, and plus 0.5 log base to 0.5, right? If you just add, so as we know that log base to 0.5 can be represented by log base to 2 to the power minus 1, right? If you just calculate, you will get minus 1, right? So here you will get minus 0.5 minus 0.5. You add, so you will get minus 1 here. So H is already we know that H is equal to minus of 1. Here you will get 1 is equal to 1 bit. So option B is the correct answer for this question. Is it fine to you? Have you understand? Just put in the entropy formula and calculate the values. You will get it. Okay. Okay, so I hope you have understand this question. Now moving to our next and last question. So question is, if an image is perfectly uniform, that all pixels have a same value, what is the entropy if it normalized GLCM for any displacement D? Option A 1, option B infinite, option C 0, option D 0.5. So if an image is perfectly uniform, all pixels have the same value, what is the entropy of its normalized GLCM for any displacement D? Okay, so let's see the explanation is here. So yeah, that's correct, Meena. So here explanation is added here. So uniform image characteristic. So in the perfectly uniform image, every pixel has the exact same intensity value, let's say V. This means that For any chosen displacement D, any pair of pixels separated by a distance will always consist of intensity value VB. So in the GLN-CM construction, so is the matrix where each element ij represents the frequency or a probability of a pixel with value I, being the distance d from the pixel with value j. For the uniform image, all pixels are like v and v. We have assumed that. That means non-zero entry in the GLCM is at any index vv. And after normalization, the sum of the all elements in the GLCM must equal 1, and since there are only one non-zero entry, it must be exactly VPPV that is equal to 1, while all other entries are the 0. So in the entropy calculation, as we have seen by using this formula, so by substituting for the single non-zero entry, that you will get 0, and all other entries are 0, so that is defined by the information theory that you will get 0 also. So the entropy of a perfectly uniform image is a normalized Gray level co-occurrence matrix for image displacement D is 0. Yeah, so option C is the correct answer for this question. Okay, so now questions have been completed. So now if you have any doubt, you can ask, otherwise we can close the session. So thank you everyone. Thank you for joining this session. Now if you have any doubt, you can ask, otherwise you can leave the session. Any doubt? Okay, okay. So now we can close the session.
Hello.
Yes.
Can you hear me?
Yeah, yeah, yeah. I can hear you.
Ma'am, for question 19,
Okay, 9. Mhm. Yes. Yeah, question
um,
19.
if we calculate Pij,
Hmm.
just the Pij, then it would be like the rows would be 0, 0.5, and the column would be 0, 0.5, right? Like if we were to construct Pij and write it down, so in the x direction it would be 0, 0.5, and in the y direction it would be 0, 0.5. So that would have only single entry, right?
Okay, but here already this matrix is given in the question, GLCM.
Okay, so Pij is only given to us. Okay.
Yeah, yeah,
I
it is
thought, I
given
thought.
0.5 and 0, 0.
Oh, sorry, sorry. I thought it was the. Okay,
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 no,
sorry.
no, already this matrix is given, so you don't need to calculate it.
Okay, got it.
Hmm.
And ma'am, question 8,
Question. Yeah, sorry, question. Which question?
question number 8.
8. Yeah, yes, question number 8.
I'm still confused about how did we realize that there are like the horizontal edges on the output image is just the window covers, right? That's it. I don't see any other horizontal bright edges that you mentioned.
Okay, so if we just analyze these images, we will just take in the upper that right corner, all the edges are glowing at the different, right? So that means that edges are detected, and this corner images are also much likely to glowing all these points, like this one, this one, this one, this one. So if you just perform the vertical or this one, so you will check this side will be glowing more,
Yeah.
right? So if you want, I can go through the Python other programming. So we can show the different directions and different ways. So it's better to understand how it is performing.
Okay. Okay.
So what is
I
your doubt? I mean, what
I
exactly?
mean, visually, I'm not able to see how it's northeast. I can,
Okay, okay. In the direction you are confused that I have written.
yeah, yeah.
Okay, don't go with the direction. So just check the top left, top right, like this one.
Yeah.
Like positive values are at the top and right. So in the top are glowing and right side. If you just check the left and right, so
Okay.
just go through that one also.
Hmm. I see. Okay. Okay. Only on
Yeah,
the right side of the wall.
yeah.
Okay, got it.
So
Okay,
right
that.
side is just glowing more.
Hmm. Hmm.
So right
Okay.
side of the wall, it is glowing.
Okay, ma'am. Thank you. I'll look at it again.
Okay.
And thank you, Anand. Um, mm, yeah, that was it from my end. Thank you, ma'am.
Yeah. Okay. No, it's not a given. Its original image is given, and there is a one kernel is given that output image that we have to just detect it. It is related to which kernel. So just seeing the output image, you have to find out. So there is a concept of positive and negative numbers already. We have explained it here, right? So if it is a positive number, then it is glowing more on that side. If it is a negative, that means the contrast or the edges are less detected. Is it fine to you, Anand? Ninad?
Yeah, ma'am. It's fine.
Okay. Any other
Uh,
doubt? Any question?
I still have a doubt with question three, but I will probably email you about it. For because explanation for question three is not clear to me. Like it's
Okay. Question number three. Okay, okay. I will go through that once again in the next class. Actually, I'm not well little bit today,
oh, sorry to hear
so
that.
uh,
Okay.
I'm not
Okay.
able to speak properly. In fact, just trying to.
Yeah, sorry to hear that, ma'am. I hope you get
No,
well soon.
no, that is
Just
fine.
let us know if
So
you rewrite the explanation at all.
yeah, yeah, yeah. I will rewrite and I will try to explain in the next class as well.
Okay, ma'am. Okay. Thank you. Thank you.
Okay.
Get well.
Okay, thank you.
Yeah, yeah. Thank you, everyone. So now we can close the session.
Yes, ma'am.
Okay. So thank you, everyone. Thank you for joining the session. Now I'm closing.